Fajan's method of precipitation titration is a technique to determine the concentration of certain ions in a solution. It is based on the concept of selective precipitation, where a precipitating agent, known as the titrant, is added to the solution containing the analyte of interest. The titrant forms an insoluble precipitate with the analyte ion. A suitable indicator is used to detect the endpoint of the titration, which is indicated by a color change. The endpoint occurs when the last trace of the analyte ion is precipitated, and the indicator forms a stable colored complex with the excess titrant. The principle of Fajan's method is as follows. The analyte ion, X car, reacts with the titrant, AgNO3, to form a precipitate of silver salt, AgX. X plus AgNO3 and AgX plus NO3. The indicator I is adsorbed on the surface of the precipitate, forming a colored complex, AgXI. I plus AgX and AgXI. The titrant is added until the equivalence point is reached. At the equivalence point, the indicator on the precipitate surface starts to desorb due to the excess titrant, causing a sharp change in color. AgNO3 plus AgXI and AgX plus AgI plus NO3. Here X represents the ion of the analyte that interact with titrant and titrand. The procedure of Fajan's method is as follows. Suppose we have prepared a standard solution of silver nitrate with a concentration of 0.1 mol L. We have also prepared a solution of dichlorofluorescin with a concentration of 0.01 mol L. We have taken a sample of a solution containing chloride ions of unknown concentration and transferred 25 millimolars of it to a conical flask using a pipette. We have added a few drops of the indicator to the analyte and mixed well. The solution has a faint green color. We have filled a burette with the titrant and noted the initial reading as 0.00 ml. We have added the titrant to the analyte drop by drop while stirring the flask constantly. We have observed the color change of the solution. As the titrant is added, a white precipitate of silver chloride forms. The solution has a more intense green color until the endpoint is reached. We have stopped the titration when the solution turns pink. We have noted the final reading of the burette as 20 ml. Calculate the volume of the titrant used as 20 ml. We have converted the volume of the titrant and the analyte from ml to L by dividing by 1000. We have obtained 0.020 L and 0.025 L respectively. We have substituted the values in the formula and solved for C2. We have obtained C1V1 R C2V2 0.1x 0.020, where C2x 0.025. C2 are 0.1x 0.020, 0.025, C2 are 0.08 mol L. Therefore, the concentration of chloride ions in the analyte is 0.08 mol L. This is how we can use Fajan's method of precipitation titration to determine the concentration of certain ions in a solution. This method is simple, sensitive, and applicable to a variety of analytes. However, it has some limitations such as it requires a stable and soluble indicator that does not interfere with the precipitation reaction. It is affected by the presence of other ions that can form precipitates or complexes with silver, or the indicator such as sulfide, carbonate, cyanide, etc. It is sensitive to the pH of the solution, as acidic or basic medium can affect the solubility of the precipitate or the indicator.
Joyce on Classes. We provide you with valuable and up-to-date knowledge about the pharmacy education. We create entertaining yet informative videos on topics such as chemistry of drugs, biochemical reaction, and much more. Hit that subscribe button and press the bell icon and join our mission to make understanding pharmacy easier for everyone. Like, share, and comment on our videos. We look forward to hearing from you.
Joyce in Classes.
The best for best.